In this video, we're going to look at the product rule for counting. If there are n ways of doing a task, and for each of those, there are n ways of doing another task, then there are m times n ways of doing the two tasks in total. So if there are 4 airports in London, and each airport has 8 airlines flying to Madrid, that means there are 4 times 8 or 32 ways of getting to Madrid. And hopefully that you can see why this is coming to. It's kind of like a tree diagram in a way. So if we've got the 4 airports, 1, 2, 3, 4, and each of those has 8 different flights going to Madrid. So then we've got 8, 8, 8, and 8. That means we have 4 times 8, or 32 different options in which to go to Madrid. So, example 16, I have 12 dress shirts for work and 18 ties. How many combinations, however unflattering, do I have of wearing a shirt and tie? So, if we think about each shirt, so for shirt 1, you have 18 different options. Shirt 2, you have another 18 different options, all the way down to shirt 12 with another 18 different options. So what we have then are 12 lots of 18, which is 216 different combinations. And this works for the formula. So the product rule of counting is that you've got m times n, and that would be 12 times 18. Example 17, in a restaurant there are 4 starters, 12 mains and 6 desserts. How many combinations of 2-course meals are there if one of those must be a main? So what you've got there is we need to look at the combinations of a starter and a main, because that's going to be one option, and the other set of combinations is going to be a main and a dessert. So if we're looking at the starters and the mains, so there's 4 starters and 12 mains, so you could have starter 1 with main 1, starter 1 with main 2, all the way up to starter 1 with main 12. So that's a total of 12 different options. And you have the same for starter 2 and main 1, starter 2 and main 2, all the way down to starter 2 and main 12. So you have another 12 options. So what we have is that we're going to have 4 times 12 options, which is 48. For our mains and dessert, well, we can have main 1 and dessert 1, and main 1 and dessert 2, and all the way down to main 1 and dessert 6. Or we could have main 2 and dessert 1, and main 2 and dessert 2, all the way to main 6 and dessert 6. So what we've got are 6 combinations for main 1, 6 with main 2, we've got 12 different mains. So that means we're going to have 12 times 6 options for a main and a dessert, and that's 72. So we have 48 combinations of a starter and a main, 72 with a main and dessert. That means we've got 48 plus 72, which is 120 different options. Example 18, year 12, there are 70 boys. The principal wants to select 2 boys at random. How many different pairs can be chosen? So if there's 70 boys, what you could have is boy 1 and boy 2, boy 1 and boy 3, boy 1 and boy 4, all the way down to boy 1 and boy 70. We could have boy 2 and boy 1. We can't have boy 2 and boy 2, but then you'd have boy 2 and boy 3, all the way down to boy 2 to boy 70. And that's going to be the same the whole way across. But what we've got here is we've got a duplication. So we've got boy 1 and boy 2 in the first combination, and we've got boy 2 and boy 1. So for each combination that exists, there's going to be a duplicated version in the other option. But those are still going to be the same number of boys. So in this example, what we need to do is we'll have to divide by 2 in the end, because we're looking for different pairs. And boy 2, boy 1 is the same as boy 1, boy 2. So for each pair, there's going to be a similar reversal of it, but it's the same pairing of boys. So what we'll need to do at the end is divide by 2. So the number of combinations we have. So in our first pick, we can have 70 different options. In our second pick, we can't have 70 because you can't have the same boy picked twice. So that means there's only going to be 69 different options, and we can see that in this first list. So we had boy 2, boy 3, boy 4, all the way down to 70. So there's 69 in here, and there's going to be 70 different options of getting that. So there's this combination with boy 1 and with boy 2 and with boy 3 and all the way up to boy 70. So we've got 70 lots times by 69. So this is our m times n, the product rule for counting. But because it is duplicates, what we need to do is divide that by 2. And we get 2,415 combinations.